Welcome back. We're doing another video and we're going to look at fitting a line through data, also linear regression. I already have it titled. I've already imported my things. I'm going to add a new one today for us. I'm going to import a new library, and it is going to be import from SciPy import stats. This way we can use the statistics packages. And what we're going to try to answer is, are the number of majors increasing over time? So what you can see is, we've had majors from 2000 to 2014, pretty good here, 10, 15. But lately we've been having, 20, 16, 21. Are they increasing? So let's see. So we can look at our data. So first we need to make two NumPy arrays. So I'm going to set the first one equal to years. So do np dot. And I'm going to use a trick because I know I need just 2000 and 2014. So I can just do np.range from 2000 to 2015. It doesn't do the last one. Now we can print years. There it is. Next we need to enter the other data, and I'll call it majors. We actually have to type this in. So I'm going to do np.array. Right, let me look at them. I'm going to see if I can type them. 10, 16, 14. I'm going to put a decimal place in there so it floats. 15, 15, 7, 13, 10, 8, 6, 20, 8, 15, 16, 21. I'll run that. Oh, we have an error. Oh, 2 there. So we had 14, 15, 15. There we go. Now I'll print majors. Looks good. We can check the length. So we can print length years. Remember, use tab to fill in. Then also we could print length majors. Up 15. Everything is good. So now we're going to plot our data. You should be great at plotting data now. We'll use our fig, x goes plt.subplots. Remember, this turns on our figure and gives us lots of control. And then what I'm going to do is I'm just going to use a scatter plot. So if I do x.scatter, I'm going to do years, majors. Oh, and there it goes. I haven't labeled any axes, but you can see it puts in our data nicely. But now we want to try to fit a line through this. We want to put a line through this data. And we want to see how the fit is. So what we're going to do is we're going to use linregress. And so now we can just do stats.linregress, and you just put in your x and your y's. I'm going to do years and majors. And there it goes. So you have linregress result. It gives you the slope, the intercept, the r value, which you can make into an r squared if you square it, p-value, so look, and standard error. So you can see, look, the slope is positive, it's increasing, but look, and the r value is 0.18, that's quite low, and the p-value is 0.51, so it's greater than 0.05, so it's not significant. But we still can do things with this. First of all, the weird thing, so it's not significant, but let's try to use the data. First thing you want to do is, so this stats then regress gives us 5 numbers. How would you save 5 numbers? There's 2 ways you can do this. You can either save it as different names, or you can give it a, you could set it into its own NumPy array. So if we do linregress, I'll do lin out equals stats. Isn't there? Now you could do print lin out. There it goes. But imagine if you only wanted the slope, you could print lin out of 0, and it gives you the slope. Lin out of 1 gives you the intercept. This way we can get our data that way. So this one function gives us 5 numbers from 0 to 4 that we can then use. So now we can go use this to put a line on our graph. So let's go back up here, and first let's get our x values. So we can do, I'll call it x fit, and what you can do is you can do we're going to use numpy.linspace to get the numbers. But where do we want it to go from? We want to go from 2000 to 2014. But what you can do, imagine this changed. We could actually look for the minimum and maximum. So what you can do is you can do minimum np.min of years And then you can do also the numpy dot max of years. We put that in, right? Everything's still running great. So we have our numbers. It's going from the lowest to the highest years. And now we'll do our y fit. I'm going to do it separately and not in there. So let's do y fit. Remember, then that's going to equal to x. Remember, y equals mx plus b, so it's x fit times the slope, right? That's our lin out 1, or zeros, right? Almost got that. And the intercept plus lin out square brackets 1. And then what we're going to do, then we need to plot those. I'm going to plot it as a line. Remember, this, since it's the same ax, it's going to put it on the same graph. So we do x fit, comma, remember using tab to help you. Ready? Shift enter. Let's see if this works. And there you go. We have this nice line, which is the best fit, going from the lowest to highest. And during class, I'll show you how to label this nicely. So this should give you a head start, and we'll learn more in class. See you soon.